Thanks, Bilal.
Yep. Thank you. Can you hear me all right? Is my microphone working well?
Yep, can hear you and see your
Okay,
slides fine.
perfect. Hello, everyone. My name is Bilal Sheikh, and I'm going to be talking to you about the BioSimulators project. So I currently work at the Car Lab, and I'm working on various projects to make models and simulations easier to use and more accessible to a wider audience. So before I get started, just want to give a thank you to the BioSimulators and biosimulations teams, as well as our outside collaborators and funding agencies. And so a big part of this project is going to be dependent on community participation. We would say that community participation is really going to steer this project and really determine its future directions. So I'd like to invite everyone to please join the breakout session. This will be on October 7th, 2020 at 1400 UTC. And there's the quick link to get to it. So the BioSimulators project is really motivated by some of the ideas that have been discussed earlier, where advancements in precision medicine and bioengineering are really going to require large and comprehensive and more predictable models. And in order to make these models, there's likely going to be collaboration required between not only those of us in the modeling community, but also experimentalists, physicians, people in various fields. And despite a lot of efforts into this area, it's still difficult sometimes to share and reuse models and simulations. And quite a few existing standards do exist to specifically help with this issue. We have frameworks that discuss the various, we have ontologies that discuss the various modeling frameworks, algorithms, and parameters, the various format languages to encode models and the simulation descriptions, as well as the tools, standards for packaging these together. So despite this, however, there are still quite a few barriers, and a lot of them revolve around the difficulties of the various simulation tools. So we have simulation tools that support various algorithms, features, formalisms, and formats. And sometimes it can be difficult to determine which tools should be used for particular models. Other times it can be difficult to download an older version of a simulator in order to reproduce something that was published. And oftentimes for novice users, it can be difficult to even install and use these simulation tools. Now, of course, for all of these problems can be overcome, but again, as I mentioned, it's difficult for those who are not already involved in this ecosystem to understand what exactly a Casau term is and how that helps them decide which simulator they can use to open up their various models that they want to try to test. So the goals of this project are really to make it easier to share and discover the correct simulator for particular use cases. So this would depend on which sort of frameworks it supports, the various algorithms that it has for simulation, which file formats it can take in as input, and also to make it easier to obtain and use these simulation tools. So we envision doing this through the creation of standardized interfaces, portable Docker containers, and cloud services to run simulations and models. So as was mentioned in the opening talk for Combine, apparently this image is guaranteed to appear in every session. I was not aware of this. This is my first Combine session. But of course, something that we want to prevent is this proliferation of standards that happens when we try to create these sort of universal catch-all standards. So one thing that we're really going to be focusing on is to integrate the existing Combine standards into this, and really only try to introduce new standards where we are trying to fill in some gaps, and really focus on creating this community-driven registry of tools to try and solve this problem. So to give a quick overview of how we plan to do this, is we're focusing on creating a standardized interface for simulation tools. And this is going to rely on the already existing standards of the Combine archive, the SetML description of simulations, and the various markup languages that exist, such as CellML and SBML for describing the models. And it'll rely also on the various ontologies, such as Casau and SBO, to be able to characterize the various properties of these simulation tools. We plan to wrap all of the simulators into standard container structures. This is going to make it easy to pull a container, run it on a given machine, and be able to look at the output. And we're really trying to introduce a new standard, and to want to emphasize that this is going to be driven by community participation. We have a sort of draft of a JSON document that we've created, but before this becomes formalized, we would really like to invite community participation into this, but to create a format that is able to categorize and catalog the various supported frameworks, algorithms, parameters of simulations, and their various features. And finally, we want to contain all of this into a registry so that these simulators can be easy to discover and access. So here it gives a visual description of what I've been mentioning. So we hope to be able to provide a Docker container which uses standardized interfaces to read in a Combine archive. That Combine archive would contain, the standard SVML files, ZML files, and hopefully should be able to output from there results that are described in a standardized form as well. So what we are really envisioning is that someone who is trying to, for example, run a model can do something like this, where they can call for BioNetGen and call for Tellurium, and using the same sort of command line interface, be able to run the models through these simulators. And of course, the simulators themselves would have more advanced features, but they would be wrapped up into this simplified container. So the format that we are proposing to catalog the capabilities of each simulator, my apologies, are going to be focused on the various algorithms that are supported by each simulator. So we have the Kazaa ontology for this, where we can assign the Kazaa ID to an individual algorithm and say that simulator X supports the following Kazaa terms. We can do similarly for the SBO ontology, which can be used for looking at the various formalisms, such as the continuous non-spatial or discrete. And we are also looking at using the EDAM ontology to look at the various file formats that are accepted and output by each simulator. And the goal of doing this is to really make it easier to determine which tools can be used, which simulators can be used for various different projects and use cases. And in addition, this file format is going to collect some basic metadata, license, authors, etc., to really be able to provide a interface where people can browse and view the various simulator tools that exist. So to begin, we've already containerized a couple of simulators. So over here on the left, you can see the ones that we've already created, as well as the collaborators that we worked with. And here are some of the simulators that we've been working on. So as I want to mention that these simulators can go across the spectrum of various frameworks. So we're planning on having logical, constraint-based, and kinetic simulators. And all of these will hopefully be distributed via the Docker Hub. So we already have a BioSimulators organization on there, which contains some of the simulators that we have been working on. The main part of this project, though, is because we're anticipating is going to be through the web app. So we have a web app that's available at biosimulators.org. And I can actually give a quick walkthrough of what this app would look like. So here we have the main page, and one can go and look at the various simulators that we currently have in the database. So over here, I have some basic information about all of the simulators, and I have the ability now to be able to filter through these based on various features. So for example, if I want to do a flux balance simulation, I can select this and see that Cobra Pi is something that supports flux balance. Similarly, I can go and look at the various algorithms that exist and determine which simulators support these algorithms. So this allows me to filter through the simulators that are in the database and determine which ones will fit my particular use case. I can also look at some more information about each of these simulators. I have some descriptive information I have here the Docker command to actually pull this container from our Docker registry. And I have here some more information about the various algorithms that are supported. And so all of this information actually it's just being pulled from the various already existing standards. So we're using Casao to be able to get the description of each individual algorithm, the name of its parameters. We're using the SBO to be able to identify which frameworks are supported. And this can provide a link out to the already existing community resources, assuming my internet connection was fast enough, to be able to find some more information about the various tools. So to give a roadmap of where we are and where we're hoping to go, so we've created some of the infrastructure. We've created this format for cataloging this information, the database, API, and the web application. We've started containerizing some simulators. Like I mentioned, we have BioNetGen, Copasi, Tellurium, and vCell currently. And now this is the stage where we're at, where we're hoping to invite community participation, and hopefully we can really get some feedback about the format that we're using to try to catalog this information, the web application features that might be helpful, and start containerizing more simulators. So if you are working with a particular simulator often and feel like you would like to participate, or if you are a developer of one of these simulators, we would love to have you on board to try and containerize and make these more accessible. And a further goal is at some point to expand some of the existing standards. So we've already contributed a couple of terms to SBO, good amount of terms to Casao. And the goal is really to be able to ensure that these ontologies are able to describe all of the features and algorithms that exist in the various tools. Right now, there are a couple of algorithms, for example, that we don't have Casao terms for, and we would need some collaboration with the community to decide, for example, how exactly do we best include hybrid algorithms into the Casao ontology. And the overall goal is to really expand the simulator formats to include greater features. So currently we have been focused on creating this consistent interface and CLI between them, but we would like to expand this into status logging, job information, various tools, various different outputs, so that the output from all of these simulators can be processed in a standardized way. So a little bit of context into this project is that the BioSimulators project, which I've been discussing, is a part of a wider project that we're calling BioSimulations. So the BioSimulators project, like I've been talking about, has a standardized interface for simulation tools and focuses on creating this registry of portable containers that can be used to run models and simulations. On top of that, we have a project called Run BioSimulations, which is hosted at run.biosimulations.org. It's in a very early alpha, so no guarantee if it is working at the moment. But this is designed to provide the ability to use these biosimulator containers to now be able to let users run these simulations on the web without needing to download any software to their own computer. And on top of the structure here, we have what we envision to be BioSimulations, which is going to be a platform for sharing, discovering models, simulations, and entire simulation studies. And here we are envisioning a user-friendly interface for taking a model that was, for example, published in a journal, running it yourself to see what the output is, using a user-friendly graphical interface to tweak a couple of the simulation parameters, submitting it again, and running it all in the web browser to try and see, how does the output change, and hopefully really be able to enhance the reproducibility and reuse of these models, so that someone can download an existing model, run it, play with it, simulate it again, and get a sense of how the model works. So just to summarize, we've been working on biosimulators, where we're working on creating consistent interfaces, container structures, and formats for describing the capability of simulators. We're working on creating a collection of containerized simulators, a web app for discovering and browsing through these simulators. And the next steps of this project are really to start integrating all of this into a web platform that can be used to make these simulation studies more accessible and more easier to reuse. And just to emphasize again, we're really, really hoping for community participation in deciding the future directions of this project. And if you would like to participate, please join us at the breakout session. Thank you very much.